Okay, for this screencast, we are going to go over two things. We're going to go over first eigenvalues, eigenvectors. So we went over how to do this for a 2x2 matrix in class. I'm just going to use the exact same example that I did in class. So I'm going to throw a clear CLC and a close all. So there's my matrix, 1, -2, -2, 1. I can compute the determinant. I see that it's -3, which means the inverse exists. I can compute the inverse of A. There's my inverse. I can also do the augmented form of the identity matrix with A in the identity matrix, and I get the identity on the left and the inverse on the right with using RREF. And now what I want to do is I want to get my eigenvalues, which is equal to MATLAB has EIG of A. So then there are my eigenvalues, -1 and -3. Now, in order to get the eigenvectors, what you actually want to do is you want to do V, I think it's V comma L equals EIGA. And then I ran that, and over here you see here are your eigenvectors, -0.7071, -0.7071, and then over here -0.7071, and then 0.7071. So if you notice, this V matrix is an orthonormal matrix. So if I do V times V transpose, I get the identity. If I do V times V transpose the other way, I still get the identity. So it means that the inverse of V is V transpose because it is orthonormal. And what I also can do with these eigenvectors and eigenvalues is I can actually decompose my matrix into V and V transpose and lambda. And to do that, I say A reconstructed is equal to V times L times V transpose. And notice, by the way, that L, when you do V comma L EIG of A, you get -1003. What they do is they put the eigenvalues on the diagonal like that. And so when I hit F5 here, notice that A reconstructed is the same thing as the A matrix that I started with. If I type in A, I get the exact same thing. There's a little bit of numerical precision error, as always, but it's still largely the same. So in MATLAB, doing eigenvalues and eigenvectors is extremely easy. Now what you can do is this helps you with the inverse because there are multiple ways to solve for the inverse. So I kind of did this too quickly, but remember when we solve systems of equations, you simply do RREF of A augmented with B, where B is the right-hand side of the equation. Well, it turns out you can actually get the inverse of A by augmenting it with the identity matrix and then doing row reduction. So IEYE is just the identity matrix. So here's I, the identity matrix. And then if I augment A with the identity matrix and then perform row reduction, I get the inverse on the right. And MATLAB also has a built-in function to compute the inverse doing inverse of A. So I get the same thing here as I do here. And then finally, I can do another way where I can actually say A inverse. I can use this guy here. So I can actually do V times 1 over L times V transpose. And notice that I get the exact same thing. So there are multiple different ways. This is using row reduction. This is using built-in MATLAB functions. And this is decomposing the matrix into eigenvectors and eigenvalues and computing the inverse. Now, what the inverse actually is if I take A times inverse of A, and for some reason it didn't like it. So it worked, and then it didn't work. Okay, I think the reason why it doesn't like this is because L, whoops. This is L, negative 1, 0, 0. What we want is L equals 1 over negative 1, 0, 0, 1 over 3. That's what we want. So let me see if I can figure out how to do that real fast. Okay, so the best way to do this is if I take L is negative 1, 0, 3. If I do L raised to the minus 1, I get what I want, where I invert both of these. So what I want is actually L raised to the minus 1. And that should be it. Okay, there we go. So basically I have the identity matrix is here, 1, 0, 0, 1. I have the augmented matrix, well, initially it's the A matrix and then identity, and then I row reduce it and I get identity on the left and the inverse on the right. I use the built-in MATLAB function, I get the inverse, and then I use eigenvector eigenvalue decomposition to get VL V transpose, and the inverse is just VL to the minus 1 V transpose. And if you look at L and L to the minus 1, all you do is just do L inverse equals minus 1 over minus 1, 0, 0, 1 over 3. And that gives you your L inverse. And that's all I have for right now. Hopefully that will help you out. Good luck.